All right. So, good morning. Hello. Welcome. Everybody can see the screen, correct? Everybody can hopefully see my screen. This is AP Computer Science A. This is Wednesday, April 8th. Today, what I would like to do with you is I'd like to start by going over the homework from last class. And then I'd like to give you, just like I did last time where I gave you a crash course on arrays and array lists, I'd like to give you a crash course on the second topic that's going to be on the AP exam, which is on methods and objects. All right, so just tell you what you need to know, and then assign you something very similar to what I assigned last time, where I asked you to write a couple methods to accomplish a couple specific goals. In my opinion, I think homework assignments like this, hold on, you know what I got to do? I got to go full screen. Can everybody see? Everybody can see the screen, yes? We can see that, yes?
Yep.
Okay,
Yes.
all right, so in my opinion, I think homework assignments like this is the answers that I typed up, are super valuable as far as preparation goes for the free response questions on the AP exam, because this is really what the free response questions are going to be. Yes, they will be tied to some real world scenario where it's going to be not just so like black and white of can you write a method that does this. It's going to be more tied to a scenario, but really it's that idea of saying, can I break down what's being asked? Can I figure out a step-by-step way to get it done? And can I return a proper result? Okay. Sometimes you will get free response questions that are just like, hey, given an array, can you write a method that finds the sum of all values in an array? That can show up on the AP Computer Science A exam. So it's important that you understand how to go about doing that and how to think about it. That's why I think these exercises are really great. So these were the notes that I gave you last time on the AP on arrays about in preparation for the AP Computer Science A exam. We had our quick little crash course on arrays. We had our crash course on array lists. I realized I actually forgot to post these notes on Google Classroom. I did that this morning, so they're there for you now. All right, so if you weren't able to see them or access them or you didn't have them, yes, the video lesson was up online, but I did just post those notes there now, so you have access to them. All right, just to go over the homework quickly, I asked you to try to write these 5 methods. This code, and again, I'm going to share this document with you at the end of today's class, is my solution that I came up with to the problem. It absolutely does not represent the only solution. There are many possible solutions that you could have done for a problem like this, but this is the solution I came up with. So if I'm trying to find the minimum value that's stored in an array, I'm going to start by assuming that the minimum value was in the first position. Then I'll keep going. Oh, I think we got Mr. Ferreira trying to jump in. Yeah, very good. Mr. Ferreira, he's arrived. Excellent. We'll get rid of that infinite recursion screen. All right, so I've started with assuming that the minimum element is in the first position at index 0. We then just went through the rest of the array. We went from index 1, no reason to check index 0 again, all the way up to the end of the array, adding 1 every time, to see, hey, do we find anything that's smaller than this? And if I do, then set that equal to whatever we found. Just by completing that process throughout the whole array, we're guaranteed that at the very end, minimum will have the lowest element. Does that make sense? Sometimes when you have to go through problems like this, it's very beneficial to actually kind of write it out on paper and think about it and be like, all right, to find the lowest number in a list, what's a way that I could do that? Well, I can say, let's assume the first one's the smallest, and then we'll just compare all the rest and see, do we find anything smaller? If so, update the smallest. So by thinking about how to solve the problem before jumping in and actually coding it, it can be a big help. It can be a big help. All right. This was my code for calculating the average of an array. Again, definitely not the only possibility on how to do that, but we just start with this value called average, which is 0. We're just going to sum up all the numbers in the list, and then we'll return the average divided by how many numbers there were. Okay? You could certainly do these calculations all separate, like you could add them up and then divide in a separate line and then return the result, but that's a nice efficient way to do it. Okay? We go for this one, which is given an array of strings as well as a specific string to search for. It returns the index at which that string is located. So all we're doing is we're just saying, go through the whole list. If we find string S, then return that index. Otherwise, we return -1. Note that you can do this because as soon as this statement of return I gets hit, if it gets hit at all, your method's going to end. So you don't necessarily need like this if-else statement. You don't need a separate Boolean variable to check for whether or not that was successful. You can just say, if that's the case, then we'll return I, and our method terminates as soon as you see return. Otherwise, if it goes through the whole list and never triggers this case, then that means it never found it, so it returns -1. Happy with that, hopefully. Okay, going to question 4. It says, given an array list of integer objects sorted in increasing order, as well as an additional integer, it inserts the integer object into the correct position in the list while maintaining the sorted order. So you're assuming that this array list has this collection of numbers that's all sorted from least to greatest. How do you find where to put a specific value? Well, I just said let's start with index 0, and I'll keep checking. While the index is less than the size of the list, because we don't want to go out of bounds, and while my value is greater than whatever value is currently stored at this index, that means we have to keep going. If I have a number that's bigger than this specific position in the list, that means, well, I need to advance to the next position. And then I'll check again. Are we larger than this specific value? If so, let's keep going. And are we larger? If so, let's keep advancing until we get to either a position where our value fits in, where it's less than the next value in the list, or where we just reach the end of the list, because that would terminate this expression. And then once we do both of those things, we can just go ahead and add. At this specific index, we can add that value. Does that make sense? Okay. Again, definitely not the only way you could have done that. There's a lot of different ways to do that, but that I think is a nice, efficient way, where I'm going to say just keep going through the list until you hit the end of the list, or you just get to a point where your value is now bigger than what you're faced with. Okay? So that's the idea. All right. And lastly, moving on to problem number 5, it says it creates and returns an array list containing n elements, each of which is an integer object with a random value from 1 to 100 inclusive. This was just a nice little exercise on how the random number generation works. Again, make sure that you know this formula, even though there's no multiple choice questions on the AP exam this year. That is a sneaky thing that likes to pop up from time to time, so it's important that you understand how random generation works. But in any case, it's just going through the list, generating a new random number, adding it to the list every time, and then we just return the list. Okay. Any question about that and any of those at all? I'm just going to tab right back over because I thought I heard something come up in the chat. Oh, just Jack saying yes. Okay, fantastic. No other questions on that at all? All right, so let's quickly talk about methods and objects. All right, methods is something we've been using a lot, so I'm not going to go super crazy into detail of this. But a method is, again, it's just sort of a segment of code whose job is to perform a specific operation. Okay, that's really what a method is. And a method may or may not return a value or any sort of data. Right? We can have methods whose job it is just to print stuff, and then they don't have to send any information back. Or we could have methods whose job it is to actually compute calculations and send back answers. Right? The way that I always compare it to a function from mathematics. Okay? Like, I always use that same terminology. A method is like a math function. Okay, where the function does something and sends out an output, a method does the exact same thing. So I always compare the two things. It's really a function. Okay, methods a lot of times have, again, like I said, specific jobs. They have specific tasks that you have to perform. And I find that a common mistake that a lot of people make, myself included sometimes, is I try to make a method that does too much. A lot of times your method has to be a very specific goal. Okay, like your method should be, if you want to take the, for example, find the sum of all values in a list, that's all your method should do. You should, if you want to also find the average of all methods in a list, or all things in a list, then have a separate method that does that. Don't get crazy with this one super method that does everything you need it to do. All right, methods should have individual discrete tasks. The syntax for a method, by the way, the header that you may see, is we use this permission of public, or you've seen private or protected before, but typically we can stick with public. We've seen this keyword static be used. We then have the return type, which you can call void if you don't want to return anything, or you can have int or double or whatever you want to put there. Then we have the method name, typically written in camel case. And then here we have parameters with specific types. So I could say int parameter 1, and maybe we have a boolean, parameter 2, and maybe we have an object, whatever you want to use, called parameter 3. Right? Okay? And then you go ahead and open your code and go ahead and put your code in there that you want to execute. Again, a return statement indicates the end of a method, and a value, or whatever value is sent back to the main program. It's sent back to wherever I should not say the main program, I should say wherever this method was called from. Okay? That's the terminology that we use. We say to call upon or to invoke a method. And when you say return, it just indicates the end of the method and whatever value is sent back to wherever the method was called from. Okay? Return means I want to send back whatever. Remember that in order for a method to work, the parameters have to match what it's receiving. So for example, to make this method work, we have to send it an integer, a boolean, and an object. If we don't send it those things in that exact order, then your method and your program are out of sync. They're not communicating with each other, so it's not going to be able to execute. Okay? Keep in mind that if you have multiple methods with the same name but different parameters, even in different orders or different number of parameters, your program is intelligent, or Java, I should say, not your program. Java is intelligent enough to make the decision as to which method it calls on. So, for example, if I also have another method called method name, say I have also public static, we'll say void method name, but this one just uses a double, right? And in your program, you say method name with just a double, your program would know, hey, even though this is called method name and this is called method name, it's going to go to the one where the parameters match up. Okay? That's a process that's called method overloading. All right, and I want to make sure that I introduce you that terminology. Method overloading is where your program determines which method to execute based on the parameters. Okay? This is a basic form, by the way, of polymorphism, which we talked about a lot more when we dealt with inheritance. This is really a very, very elementary form of that, like a very basic form of that. Okay? So that's the idea of how methods work. Hopefully we don't have any questions on that. I think methods are pretty self-explanatory. We've used methods a lot right now. The big point I want to emphasize, though, is the fact that methods should have a specific goal. And that's the really important thing about a method. A lot of times people try to think too big for a method. A method does one task. It does this thing. Okay? And the benefit of implementing methods into your code is that it helps organize all that information into one convenient spot. A great example I always bring up is Aspen, which is our grade book. A very common operation that Aspen has to do is calculate the grade average of every student. Do you think it does that 1,500 times for every student in Cumberland High School? You think there's 1,500 blocks of code that all calculate the average? No, there's one block of code that is called upon that many times. Okay, so rather than having to type that out all those times, you just call upon that one method. Does that make sense to everybody? So it's good for any repeated actions. Okay, it also just helps give your program a nice sense of organization. All right. Going on from there, we can then go ahead and create these things that are called objects using methods. Okay, and objects are a really big deal in computer science because Java is an object-oriented language, meaning that if you want to, and by the way, the common acronym of OOP is object-oriented programming. If you want to get into coding in Java, like you want to pursue computer science as a career, objects is the name of the game. Objects are hugely emphasized. They are extremely important. Please make sure that you don't overlook that, all right? The fact that it's really all about objects. Now, the way objects work is there are really three components to any object. So any object really has three components. Okay? The first component are your global or your class variables. I've seen them referred to as both terms. They're global variables, object variables, class variables. Some people call them instance variables. They're really all the same thing. Where a global or class variable just refers to what pieces in that specific object are, what's the word I want to use? What information is relevant to this particular object? What are different traits that this object has? Because an object is just a way to, I guess I should have probably given you the definition. It's a way to actually, create a structure to represent a physical or abstract thing. So this represents a physical or abstract structure. Okay? So, like, for example, if we were to create an object that represented a rectangle, I think geometry has a really good crossover with this. Well, what's important about a rectangle is the length and the width. So those would be your global or class variables, right? And you could pretty much figure everything else out, like the perimeter, the area, the length of the diagonals, etc., all from the length and width. So those would be your methods in order to do that. Anyway, so we have our global and class variables. We have our constructors, which help initialize or create the object. And we have our methods. Okay? Included in these methods sometimes is we have these things called accessors and mutators, which is also known as, oh geez, I can't type, getters and setters, if you want to use that terminology as well. This is the terminology I think gets used more in industry, getters and setters. Accessors and mutators, though, is what the AP College Board likes to use, so it really means the same thing. All right? So, if I wanted to create an object, like for example, I want to use my rectangle. I think that's a great example because it really is a great structure for an object. We could start with public class rectangle. Okay. Suppose that, again, my two variables, I have my class variables. What's important about a rectangle? We have the length and we have the width. Okay. So that would be my class variables. My constructor, I would now say public rectangle, and it is important for the name of the constructor to match this. What a constructor is again, that's the segment of code that when you create a rectangle object, this is what happens. It really is to allocate that piece of memory to your rectangle. We need to pass in a length and a width in order to do that. And I could just say this dot length equals length, and this dot width equals width. Again, as Ryan mentioned at the start, making sure that this dot is on the proper side, right? This means that I'm setting this length, in other words, the length contained within this class, equal to the one that's provided. You really only need the syntax of this dot if you want to have the same name here. Like if you called this L and you called this W, you could just say length equals L and width equals W. You don't need this dot. A lot of times, though, programmers like to have everything named the same, so there's really no ambiguity as to what specific things refer to. So either way, if you want to do one thing or the other, totally up to you. Okay. A lot of times, it's also good practice to have a default constructor. Just in case no parameters are provided and somebody wants to create a rectangle, it doesn't mean that your program should explode or crash. By default, let's go ahead and make a length of 1 and a width of 1. Typically, this is just, again, your default. If no information is provided, it doesn't mean that your program shouldn't function at all. It just means that let's have some default information here just in case. Okay, so I set your length equal to 1 and width equal to 1. So there's my constructors. We have a 2-argument constructor, which is what this is usually referred to, by the way. Constructors are usually referred to in the context of how many arguments or how many parameters they have. So I'd call this a 2-argument constructor. I would call this a 0-argument or a default constructor. Okay. And then last but most certainly not least, we would have your methods. So methods can be as simple as, area, which would just be length times width, or they can be this really complicated thing that, really they can do whatever your object needs to do. One thing I want to mention about accessors and mutators. So notice that I did not put public or private in front of the double length and double width. If you put nothing, I believe it defaults to public, I'm pretty sure. But we can go ahead and specify that if you want. It's not always beneficial, though, to make everything public. A lot of times, especially passwords or sensitive information, it's good to keep as private. If you do that, you're going to need an accessor and a mutator down here in order to get and change that. Okay? So just a quick accessor, for example, if I made my length, let's just make it private for the sake of it, right? If I made both of these private, we would need some accessors and mutators. So I would need my accessor that says public void. Let's actually public double get length. This is my accessor. My accessor means I want to access what the length is, and I can say return length. My mutator, public void set length, could be, now I want to change the length to double, say new length, and we could say length equals new length. Now again, you might be like, well, what is the point of that? Can't I just leave these as public and it's really no problem? Yes, for the purposes of AP Computer Science A, yeah, it's fine. In the purposes of real industry programming, however, you're maybe going to want some checks in here before you just allow the user to access whatever information you might be looking for. You may have a check here to say, like, if the user is logged in, right? Do they actually have access to this information? If the information is valid at all, right? You might have some other check to say if the information is up to date, updated, right? So in real industry, that's why these things are used, because there's a lot of different checks that could occur to say, hey, do I have an authority to release this information to you? I don't know if I do. So that's why getters and setters are used in real life. But for the purpose of our AP Computer Science A, it's important to just get familiar with that syntax. Same thing's true with a setter. If you're passing this in, you may want to have an if statement to say, like, hey, is new length like greater than 0? Is it even a valid thing? You may want to have something that says, are we even allowed to change the length? So there's a lot of different things that could happen. So that's why getters and setters are used specifically. Does that make sense? We would then just copy them really for the width, like so. And right here. And one more. And there we go. We should be all set. Okay. So there's our accessors and mutators. Accessors get and mutators set. Okay. Getters, setters, accessors, mutators. Okay. The last thing is just any other methods that this object is capable of. So for example, a great one in a rectangle could be to set the area. So let's say public double calculate area. We don't need to pass in any information because in this rectangle object, we already have that information stored up at the top. So I can just return length times width. Okay, and we could have another one that's like public double calculate perimeter. Again, we don't need to provide it with any information because we already have the length and width of this rectangle. So I can say return 2 times the length plus 2 times the width. And lastly, maybe I'll make a Boolean one. So we can say public Boolean is square. Is it a square or not? And I could say let's return is the length equal to the width. Okay. Does that make sense to everybody how we were able to construct that? Hopefully it does. Again, notice in a separate program now, in order to create that and access all of those things, the syntax I would use if I want to create now a new rectangle in some other program that has access to it, I would say rectangle r equals new rectangle. And let's say we make it 5 by 7. That means that the length of this rectangle would be 5 because that would get passed right into here and stored here. And the width would be 7. That would get passed into here and stored here. Okay? Now that I have that, I can go ahead and call upon all of the different things that this method could do. So for example, I could say system.out.println r dot, and remember the period is how you access specific parts of a method, or specific parts of an object rather. I could say r dot calculate area. Okay? And what that would return is that would return and print 35. That's 5 times 7. Does that make sense to everybody? Okay. Notice if you wanted to change, suppose that these were public, you can't do it when they're private. Right? If these were public, you can now change the value of these things or access the value if you just say r.length equals 9. Now your length is 9. r.width is how you'd access the width. Okay, so these are just the variables of length and the variables of width. To call upon a specific method, that's where you need the parentheses. So that's how Java is able to differentiate between what's a variable, where you just say r dot the variable name, and a method would look like that. Okie doke. Good practice, though, to keep things private if necessary. But again, for our purposes in AP Computer Science A, and I'm sure on the AP exam, I don't know if private public is going to actually come up, but just be mindful of it. Okay, just be mindful of it. The nice benefit of this too is this allows us to create multiple instances of the same object. So for example, if I call this R1, I can make another rectangle. R2 is equal to new rectangle. And let's say we make this 4 by 4, right? Well, now I have two instances of the rectangle object. So now I could say R1.calculate perimeter, R2.calculate area. There's all different things I could do by creating multiple instances of this object. Notice I didn't have to copy paste the code 2 times or however many times. What if you want to make 100 rectangles? I don't have to copy paste the code 100 times. I just create 100 rectangles like this. And maybe you could even do it more efficiently with a loop and reading data in from somewhere. Okay? The last thing I want to mention about this is you can definitely store all of these things in an array or in an array list. So if I wanted to make an array of rectangles, I could say rectangle, because it's now an array of rectangles. We can call it, we'll call it rectangles. Okay, equals new rectangle. And we could say it has size 2. And then we could go ahead and just store all of these things in there. You could also do this if you really wanted to. If you already know that you want to put R1 and R2 in there, do that. Bang, there you go. You got rectangle R1, you got rectangle R2 stored inside your array. Okay. If you wanted to make an array list, you could do array list of type rectangle. You can call it rectangles equals new array list of type rectangle, and then with the open close. And then you would just do rectangles.add R1 and rectangles.add R2. Okay, does everybody see how that works? Up here, suppose I want to call this rectangles array, just so it's not confusing. Make this rectangles list. Let's just call it rectangles, so it doesn't go to the next line. Here I could say, if I really wanted to, watch this, watch this, watch this. At index 0 equals R1 and rectangles array index 1 equals R2. Right? There's a lot of different ways that you could go ahead and set that up. Yes? Now, if you wanted to call upon a specific value of that, you could say, it's referring to our array, you could say system.out.println, something like rectangles array at index 1 dot calculate area. So that will get the specific rectangle that's stored at index 1 and calculate the area of it. You could do that from the array list as well. You could say system to do it from an array list .out.println. We could call it rectangles .get at index 1 .calculate area. Okay, so really the same thing from just the array list versus the array. Okay. Any questions at all? I know I've talked for a while, and I'll check the chat in just a minute. Any questions on arrays, or sorry, not arrays, although arrays questions are welcome too, on methods or objects or how they work and the syntax and all that good stuff? We're all happy with that? Anything come up in the chat? Nothing. Nothing. So I guess we're all good. I guess we're feeling great about it. All right, so what I'm going to do in time for next class, I know we're just about a minute over, I am going to make sure I send out another homework assignment very similar to the one you had last time, where I am going to ask you to write a couple methods and work with a couple objects that accomplish specific goals. Like I said, I think questions like that are excellent practice for the AP exam because that's really what the AP exam questions are going to be. They're going to say, hey, here's this object. Can you fill in the code to make it do something? Here's this method. Can you make it accomplish a specific goal? Maybe it'll give you the object all done, and it's going to say, okay, now in a separate program, can you create an instance of that object and then, or create a list of those objects and then work with them in some way. Okay, so that's what I'm going to try to prep you for. All right. Last thing I want to remind you of is if you did not get my email about changes to the AP exam, please make sure that you let me know, or please make sure that you review that email. Very, very important. A lot of stuff. I am going to send out a couple extra bits of information that I was told today from administration at the high school, so I'll make sure that I get that out to you as well. All right. But if you don't have any other questions or concerns, that's all I got for today. So thank you for your attention and focus. I hope you have a great weekend because I won't see you before the weekend. So enjoy, get some rest, get some relaxation, but make sure you stay on your AP Computer Science A. All right. Thanks, everyone.
Have a nice day.
Have a nice day.
Have a good weekend, Mr. Giorgio.
Later. Have a good weekend.
Have a good
See
day.
you later, Mr. Giorgio.
See ya.
Have an amazing weekend.
I will. You do the same. You do the same.